Okay, we've got a ceiling function integral today. Integral from 0 to 100 of the ceiling function of the square root of x. So if we plot that quickly, just a little sketch, what we'll see is that it kind of falls over like this, the other way round to the x squared graph. So if we take the ceiling of this, what we're going to end up with is kind of a series of rectangles as it goes up and across. So we'll think about the function over different domains. So if we have our domain on the left and our function on the right, when we're between 0 and 1, the square root would be 0 point something, so rounding that up will give us 1. So when we're between 1 and 4, the square root would be 1 point something, so that will round up to give us 2. And again, between 4 and 9, it will round up to give us 3. This will keep going until eventually we have 81 and 100, rounded up to give us 10. So what we have here then, this is the height of our rectangle, and these are the widths of each rectangle. So we can try and write these in terms of n, say the height of our rectangle. So we're going to have n multiplied by, this is going to be n squared, and this is n minus 1 squared. So n squared minus n minus 1 squared. Expanding the inside of this bracket then, this thing will become n squared minus 2n plus 1. The two n squareds will cancel off, and then we'll have minus 2n, so plus 2n, and then a minus 1 as well. Expanding this then gives us 2n squared minus n. So our integral then is going to be the sum of all these rectangles. We have to think about what n starts at. Well, this was n, and this is going to be n, so we're going from 1 to 10. So I is equal to the sum from n equals 1 to 10 of 2n squared minus n. The sum of the squares from 1 to n is equal to n plus 1, 2n plus 1, all divided by 6. And the sum of just the numbers, again from 1 to n, is equal to n plus 1 divided by 2. So we need to evaluate this one twice, this one once, but do a subtraction for this one. So let's plug it in. We'll have n as 10, so our entire integral is equal to 10 times by 11 times by 21 divided by 6. But then we've got two lots of that, so times by 2 as well. And take away 10 times 11 divided by 2. If we look at the first one, this gives us 111. This would give us 42, which divided by 6 gives us 7. So altogether that's 770. Here then, we'll have 110 divided by 2, so 55. So altogether, final answer, 715.